Hello again, everyone, and welcome to another video lesson. We're going to continue our conversation about air pressure, specifically about isobars. A lot of this lesson that I'm going to teach you in this video is going to be a recap of what we did in our live session, but we're going to really put this to use and put this to practice with a few worksheets. So, I want you to copy down the notes along with me as we go about this, and I'm going to add a few more things to this as well. And as you took notes on a separate sheet of paper in our live session, you can also add in a few more things from that to these notes to prove to me that you were paying attention the entire time we were talking about isobars. Now, if you recall, isobars are really showing us information about air pressure. We took a look at a sample map, which I have over here, right? This is just a sample map, so I'm going to label that as a sample map. And we started off by defining what an isobar is. And to define it, we took a look at this map right here, which is an example of an isobar map showing isobar lines. And we notice that these lines are labeled with numbers, okay? What we did is we went back to our lesson about our introductory to air pressure, and we discovered that these numbers are very similar to the average air pressure on Earth, which is 1013.2 millibars. What we noticed when taking a look at this map right here, sometimes we have isobars that are higher air pressure, like 1024, and sometimes we have lower pressure, labeled in 1008. It's not always that air pressure is sitting around 1013.2. Sometimes it's higher and sometimes it's lower. And as a result of higher and lower air pressure, we get changes in weather, which means that air pressure is really, really important in terms of understanding how weather changes throughout the day. That being said, let's just quickly define isobars and talk about what you might see with respect to air pressure and those isobars. So isobars, they're lines that connect equal points of air pressure on a map. Now let's think about what that means. Let's go back here. If an isobar, which are these lines, connect locations of equal air pressure, well, this would be an air pressure of 1016 millibars. Let's say there's a city on the line here, and we're going to call that city A, and there's a city on the line over here at city B. They're both sitting on the 1016 millibar, so both city A and city B have an air pressure of, you guessed it, 1016 millibars. But let's say I have a city of city C sitting in between the 1012 millibar line, which is right here, and the 1016 millibar line, which, as you saw before, is right here. What about city C? City C is sitting in between 1012 and 1016. We know it's not 1012 because it would be on the line. We know it's not 1016 because it would be on the line. So city B is less than 1016, but more than 1012. So it's somewhere in between. It's in a range from 1012 to 1016. Now, you don't have to copy this down, but this is just a visual for you to understand that if I have a location that is within a line, inside of a circle, or outside of a circle, then it cannot be that air pressure that it is. Like, for example, this dot right here, let's call it city D. What's that air pressure? Well, we know it's inside the 1024 line, and we're increasing in pressure as we go further and further and further. We know that it's got to be higher than 1024, but how much higher? That's a question that we need to ask ourselves. Well, when I look at this, I see that this is 1020, this is 1024, and then it goes to 1016, and then it goes to 1012, and then it goes to 1008. These are in intervals of 4 millibars. And what you're going to notice when you look at an isobar map is that all of these lines are going to be in 4 millibar increments. They'll all count out by 4. So here's 1008, 1012, 1016, 1020, and 1024. So we're going to notice that each one of those isobar lines is going to be up in an interval of 4 millibars, which means for something like city D, I know that I cannot get to 1028 because 1028 would be my next line, and if it was 1028 I would see a 1028 line. I do not see a 1028 line, so D is somewhere between 1024 and 1028, but it can't be 1028 and it can't be 1024 because then it would be on a line. So it's somewhere in between that range. You will also notice on these maps that there will be a large capital H centered on the highest pressure of the map, and there will generally be a large capital L representing the low pressure on the map. We'll talk about this later as to why they are blue and red, but hopefully by this point in time you understand why. It's because that high pressure is cold, dry air, and that low pressure is warm, humid air, giving their different densities and allowing different flows to happen. So now that we're taking a look at this and we're seeing that these are lines on a map that show locations of equal air pressure, and these lines are called isobars, and that we also understand that they are intervals of 4 millibars, it's really our goal to try and draw and create something like this. Okay, that's the goal here. So you know, in our main lesson, I went through going through some of these maps and kind of drawing it together. So we'll do an easy one and then we'll do a hard one together and take a look at that as well as practice, as we did in the live session. But one thing that I did mention to a few of you is that to draw isobars in some scenarios, what you need to do is you need to encode those air pressures. And what I mean by that is that sometimes when we take a look at these numbers on a map, they will look something like this, like 101 or like 996 or a 241, something like that. And they're not going to be in these intervals of thousands, right? You're going to see them and it looks like a number, okay? Our job is to encode these numbers and decide what their actual air pressure is. So let's say I have a 101. I need to convert that into an air pressure that is easily understandable in millibars. So to some of the classes I said, what we need to decide is what goes in front of that 3-digit number. Would it make sense for a 10 to go in front of it or a 9 to go in front of it? So I had a conversation with students. I said, the highest air pressure ever recorded on Earth is 1080 millibars. That's a world record. Now, the lowest air pressure on Earth is at the top of Mount Everest. It's like 300 millibars, but that doesn't really count. So I said, what's the lowest air pressure you've probably experienced in New York City, Scarsdale, tri-state area? It's probably sitting around like 960 millibars. And the highest that you've probably ever experienced in Scarsdale is probably like 1030 millibars. So this would be like an acceptable range of the highest pressure you've ever experienced and the lowest pressure that you've ever experienced in your hometown. So that being said, if we know that this is the lowest number and this is the highest number, we need to make sense of these 3-digit numbers to convert them into an easily understandable millibar labeling. And to do that, we take a look at the 3-digit number that is given to us, and we need to decide whether or not a 10 or a 9 goes in front of it. Well, if I put a 9 in front of this, that's going to be a 910, and then we put a decimal place in between the last 2 digits there, a 910.1 millibars. Does that look like an acceptable number to be an air pressure? Well, the answer, of course, is no. It is not an acceptable answer. So if I'm trying to figure out what the air pressure is of 101, the first step that I need to do for any of these 3-digit numbers is to first put a bullet point in between the last 2 digits. Okay, so there I am right there. I took the 101 and I put a bullet point or a period in between the last 2 digits. And now I'm going to put a 10 in front of it because 1010.1 seems like a reasonable air pressure that one could experience at an area as it falls in between the ranges of what is the highest and lowest possible air pressures that one could experience. So how am I going to make this a little bit easier to understand? Something like, and I know this said 996, something like this, it wouldn't make sense to put a 10 in front, right? Because if I put a 10 in front, that'd be a 1099.6. That doesn't make any sense. So what goes in front of this? A 9. And what's my answer? 999.6 millibars. So how can we make this easy for us to encode air pressures if they're given to us in a 3-digit code? So I'm just going to type this in here, and then you can add it to the notes. To encode, what we are going to do is if the 3-digit number is larger than 500, then we put a 9 in front. Obviously, if it is less than 500, you put a 10 in front. Okay? Now, of course, we could do an example. Okay? So if I have, say, 240, okay? What's that going to convert into? Well, it's less than 500, so I put a 10 in front. I put a 2, I put a 4, I put a 0. And then the last thing is the decimal. This is an example. Decimal between the last 2 digits. Jeez, I mean, it's so hard to write on an iPad. I used to have absolutely flawless penmanship, and now it's gone all to nowhere with this iPad. I don't know if I should keep it, guys. What do you think? Write in the comments below. This is like a YouTube clip, right? So really what we're trying to do here is decode. Now this decoding, will it show up on the test? Yes, but not in the context of isobars. I'm going to actually have it in the context of something at the very end of this unit, but I just wanted to show it to you here because it has to do with air pressure. And for some of these maps, what they end up showing you is the encoding numbers of that. And I kind of want to put that in as a tougher question on the worksheet that you guys have to hand in with me on this. So let's talk about how to draw this, okay? So what we need to do is we need to first find the highest pressure on the map and label that with a blue H. It's got to be a blue H. Why blue? Well, because blue represents a colder, drier air, and high pressure is cold, dry air. We also want to find the lowest pressure, and we want to label that with a big, large capital L because that's warm, humid air, the least dense of all air. When I find that highest pressure, and I label it, and I find that lowest pressure, and I label it, what I next need to do is I need to start drawing these circles of isobars around them. And I think it's easiest to start with either the high or the low. It's really up to you. And then start drawing your intervals of 4. This is really important. That it's got to be in intervals of 4, okay? From that high or from that low. And that's what makes it quite easy. So once I find my high, I'm probably going to be looking for numbers that are higher air pressures. 1024, 1020, 1016. We're going to draw an H. And we're going to draw those intervals of 4 around that H because those are higher air pressures. If I'm starting with the low, we're probably going to be starting with lower air pressures, probably somewhere around here, 992, 996, something along those lines. Okay, now clearly in this map, the lowest air pressure is 1008. But just look for the lowest numbers on the map. That's where you're going to put your L. Find the highest numbers on the map. That's where you're going to put your H. Okay, so let's put this into practice here in a very, very, very simple map, this sample map that we have in the upper right-hand corner. Okay, so although this is not relatively realistic, we see that there's a bunch of thousands. Those are my lowest numbers here, so I'm going to put a big red L there. Okay, and I'm going to put a large blue H here because those are my highest numbers of 10, 12. Then what I'm going to do, just going to pick the color green to keep things distinguished, is I'm going to connect all the areas of equal air pressure, and then I'm going to label it 10, 12 millibars. Connect areas of equal air pressure. I'm going to label it as 1008 millibars. Connect areas of equal air pressure, 1004 millibars. And this looks relatively simple. And it is, because this is not realistic. This is not what real maps look like. And to be honest, this is not really what a real isobar map looks like, but it is a good way to understand how these isobars arrange themselves. They either do one of two things, right? They either slither like a snake throughout the entire map, or they encircle in on themselves. That's really the only two options. The one thing that you cannot do, and this is like the cardinal rule of isobars, they can never cross each other. I can't have an isobar go like this and then another one go like that, because if this one's labeled at 1016 and this one's labeled at 1020, then heck, what's the air pressure at that location? Is it 1016 or 1020? Well, it's neither, because that's not possible at all. So isobar lines, they can never touch. If you want to write that down, that's great, because if they touch, then it doesn't make any sense. So if I have you draw isobars on the test and I see them cross, you understand that I can't really give you points for that. So let's follow the rules, do a really simple one together, and go from there. So when I look at this map, the first thing that I want to do in following my directions and follow my rules is find the high and find the low. So I'm looking for this thing. I'm trying to find the highest air pressure on this entire map. And you might say, well, it's 1,888. Keep in mind, those are zeros, but this is like a 1990s map from a Mac computer of like from 1927. So they put crosses through the zeros for some reason. But so that's 1,000. All those numbers are 1,000. This would be 1,004, 1,008, 1,012. That being said, let's find our highest or find our lowest. I see my lowest over here at 996. I'm going to switch over to my highest, and I see my highest over here at 1012. Notice how I'm placing my high and my low kind of in the center of where the highest numbers are. Now, if I see an absolute lowest number, which we will in our next example here, then I want to put that high pressure or that low pressure directly on that lowest number that is available to me. But being that this is a very vague, very generalized type of map, it's going to be a little bit easier for us. So what we want to do is we want to start in intervals of 4 around that high or around that low. Before, in most classes, I started with the high. So let's do the low here. 996 is an interval of 4, so what we're going to do is we're going to put a dot on the 996 and a dot on a 996, and we're going to connect them, and they're going to encircle themselves around that low, and then we label it as 996 millibars. Now I need to go up in an interval of 4, and that's perfectly kind of set up for us here on this map, and we're going to put a dot on all the ones that are the next interval of 4, which is 1,000. So I put a dot, put a dot, put a dot, and then I simply connect the dots in a nice, beautiful, smooth line, and we label it as 1,000 millibars. On the next one of 1,004, I see I don't even really need to draw dots because it makes a nice, beautiful line for me. And I label that as 1,004 millibars. Now you might be wondering yourself, well, Mr. Richards, what about this line over here? There's an 1,004 here and there's 1,004 here. And I've seen many students kind of continue that line across. I've seen some students kind of just draw a line across here and label it 1,004 millibars like that. And they might, bring this across like that. Label that as 1,004 millibars. Or I've seen some students, like I did in my live lesson, draw a continuous circle around the whole thing, which is also appropriate. Now, some of you might have said, well, Mr. Richards, before you drew 1,000 and I see thousands over here. Why didn't you connect those 1,000s? Well, because I saw that there was 1,004 in between that, and it wouldn't make sense to connect the lines because then they would cross. So we'll connect all our thousands here. Make a nice neat line, label that as 1,000 millibars. I'm starting to see my next line of 1,004, a nice beautiful line here. You can start to see how this really comes together nicely. And I would say this is, pretty appropriate to a test level question that I would give. 1,008, starting to make this nice circle here around that high pressure. And then we got this 1,012 right here. And what you'll start to see is kind of like a pattern, right? These isobars are starting to circle in on that high and circle in that low, just like they did in our sample here. So that's really what we should be looking at. And it kind of makes sense, right? Like if I'm building up and building up and building up in pressure until I get to my highest possible pressure, they should encircle themselves in that, remember, 4 millibar increment. Right? Not 2, not 6, it's 4 millibar increment. So, although this might be more representative of a test level question, what is realistic? Well, realistic would probably be something very similar to something like this, where we have a whole bunch of different isobars, spewed throughout the maps incredibly randomly. And there's a number of different ways that we can go about this. Really, we got to scan this map. We got to look for that high and we got to look for that low. Now, in class, with many of you, we started with the high because that's the easiest to find. We're going to start with the low here. And when I look at this map, it's kind of hard to find the lowest possible number. And I think I see it right here in South Dakota, which I didn't even know was still a state. Kidding. In class, we discussed that the highest pressure we found was up here in Maine, and we did discover it was a state as well. But this might not be the only highs and the only lows that we draw, so we're going to work off of this and then see where we can go from there. So what's the first increment of 4 that we can work off of from that low pressure? Well, there's 1,004 that it's on it. So what I'm going to do is I'm just going to put a dot on 1,004. I don't see any other thousands of 4 or anything less, so I'm just going to draw a circle. And that's going to really be my low pressure. Maybe there might be 1,003 there or something, but the map is really not detailed enough to show me. So I'm just going to draw a representative circle for 1,004 millibars to represent that low air pressure. And then I'm going to move on to my next one, which is 1,008. For 1,008, I want to find all my 1,008s, so I know that I need to hit them. Now, sure, I might miss a few, but the idea here is that I find as many as I possibly can, and then as I'm going along, I might be able to find a few more as I'm crossing through them. So I'm finding every 1,008 in the general vicinity, and I know that I need to connect those lines in some way. But at some point, it gets kind of difficult, right? Because, yeah, these lines right here connect to each other, and I want to connect to that one, but can I? Well, what you have to do is you have to look at the numbers that I'm crossing in between. And here I see 1,005, and here I see 1,011. I know that 1,008 is in between them, so I put a dot, and I connect that dot. I know 1,008 is in between 1,006 and 1,011, so I can put a dot in between it, and then I can connect to that 1,008. I know that 1,008 is in between 1,006 and 1,010, so I put a dot in between it, and now I can bring that line and I connect it like that. Then I can connect it like that. Okay? So now I got my nice smooth line to get all those 1,008s, but I got to get this 1,008 right here. And I know that 1,008 is in between 1,009 and 1,006, so I got to loop it back here and then hit that 1,008. Then I can hit that 1,008. I know 1008 is in between 1011 and 1005. I know 1008 is in between 1009 and 1007. And on down the way that we go to try and get in between those numbers. And we're getting closer here. So it's not an easy task here. 1008 is in between these two, right? And then it's in between these two numbers, and it's in between these two numbers. So I simply draw it around like that. And as tough as that looks, that represents my 1008 line. Now you might be saying to yourself, oh my gosh, what did Mr. Richards just do? Please, please, please do not worry about trying to understand these isobars at this level. This is just to show you what realistically these isobars start to look like on a map, and also to help you understand that, you know, not everything's going to be perfect where the numbers match up perfectly to the actual 4 increment isobar lines. We have to look at what reality presents itself with, which might be slightly different. And what reality shows us is that these isobars are, one, not created equal. They are varying spaces apart, and as a result of that, we get very drastic changes in weather. And that's why I'm showing you this here. So we can bounce it up here to the next increment. So 1012 would be next. So I'm just going to start with the 1012 that I see, and I'm just going to go in between numbers that I see. So in between these two, in between these two, in between these two. It's got to be here. In between, I'm going to erase this because that's when I was making a point. Okay, 1012 is in between these two. It's in between these. It's in between that. And then it kind of goes right off the map, right? 1012 kind of goes off the map here because I don't see any 1012s, but I know it's in between that 1011, 1013. So I got a line started here for an 1012, so I'm going to draw that out as neatly as I possibly can. I'll label at the end, 1012. We can keep on going here. It's going to be closer to this. It's going to be in here. I got 1012 there, and on down the line I go, and I can continue to hit these as much as I possibly can. And now I'm hitting a roadblock here. Starting to hit a roadblock. Which way do we go? It looks like we're kind of like off on our own here because now this 1012, I don't really have a spot for me to reach. Does it look like it has an opportunity? I mean, I see one here, but I can't enter through this way, right? Now I see a 1013 up here. So what I need to do is I need to work my way back up, it looks like, and kind of hit into Montana to find an exit for that 1012. And even then, I don't really even see one. So the question really remains is there a 1012 that comes through this area? Technically, there should be, but there's not enough data on this map to prove it. So what we're going to do is we're going to kind of end it at one point and see if we can find the solution later. I'm going to erase this and see if we can find it later. Let's move up to 1016 because clearly there's an opening for 1016 on the edge of the map right here. We're going to go in between these numbers and kind of capture that 1016 as best as we can. Now I'm starting to see the 1012 number coming into play here. See the 1012 there. Just finish off this 1016. We can bring that off the map right there like that. Beautiful 1016 number, nice and easy for us. We'll label that as 1016 millibars. Now I saw these 1012s. I'm gonna dot those 1012s because they're available to us. I see that 1016 just sitting in the middle of nowhere as well. I see a 1016. Oh, that's a 1013. Okay. I see these 1012s, and I gotta capture those 1012s. But it looks like I got a slew of pressures kind of coming up here. So I'm going to bring this up like this, and I'm going to hit that 1012 right there. And that makes sense. Why does it make sense? Because 1012 is in between 1013 and 1011. So I'm hitting that 1012, bringing it back down. Notice how I wasn't worried once I couldn't find an entrance, right? I moved on to the next one. and then I waited until I saw something different. I got to find out where 1012 then goes after this, which now looks pretty difficult, right? Because I'm not really seeing an exit strategy here, right? I do see a 1012 up here, but maybe I have to start with a 1012 coming across. Let's see. Oh, maybe we're just going to have to move on to a 1008 again. Or a 1016. You're going to have to decide. Or you could go back to the high pressure and then restart. So 1028, just like we did in class. 1028. Right there, in between those two numbers. Hit that 1028, come up here. Hit that, come down. I got my 1028. Then I go to 1024. 1024 is in here, in between there, in between there. There's a 1024 right there. There's a 1024 right there, and they all connect. 1024. And then we can move down to 1020. I got to find an entrance. Well, here's a 1020. We remember doing this one in class. All those 1020s in a nice, beautiful line, but then things got a little weird. It's in between that one. It's in between that one. It's in between this one right here. There's a 1020 right there. It's closer to this one. We hit that 1020, and it kind of goes zigzaggy all the way through. Coming through these two, and then a nice beautiful line just like that. Tidy it up a little bit, best as you possibly can. We label it as a 1020. Now we're still trying to figure out what's going on in the west here, and I'm thinking about it as I go, and I think there's going to be isolated low pressure systems on that west coast as those mountains are creating some issues with pressure. So just, you know, if you get stuck, obviously you're going to move on to a different area. 1016, do I see an entrance down for 1016 down here? I do. There's a 1019, 1014, so here's a 1016 opening. It's in between these two. I got to hit that 1016, that 1016, that 1016, that 1016, and I see a bunch of 1016s here that I got to hit. All right, I got to get those, so I'm going to go whoop, like that, zig down, get all of these. How am I going to get, oh, no, don't do that to me. Let's start over. 1016 comes down. And it's going to go in between that, come down, get that. It's going to hit those. I'm going to smooth that line out. Perfect. In between these numbers, hit that 1016. Then I get real tight in here because there's a big change in pressure. Okay, 1016 is in between all those numbers, so I'm going to take a nice line. I'm going to bridge them together, nice and neat, or at least neat as I possibly can. I look down in Florida to see if I can see any other 1016s. I do. I see a 1016 down there, so that's going to be its own 1016. I make sure I double check for that. Everything else here seems appropriate because it's in between the 1012 and over here the 1016. All those numbers are in between, so I double check out there. So I continue onto the west coast. Continue to get that 1016. I put a dot. 1016. I put a dot. 1016. I put a dot. And oh my goodness, we finally got that 1016 to make its way across the entire map. And now it's starting to look like an isobar map, right? Okay, now that 1012 that was giving us a problem before, where can we go with it? Well, we're going to have to kind of put a Band-Aid on this one here, because what I'm seeing is a new low pressure starting to come in. Why is that? Well, this one right here is 1007, okay? And everything else around it is a much higher pressure, which means that's an isolated low pressure system. Now, you might say, well, Mr. Richards, it's not the lowest one on the map. You said the lowest one on the map is in South Dakota. And yes, that is true. That was 1004. But this one is also a low pressure system because everything else around it
is lower. That's really what defines a low pressure. If everything else around it is higher. That's what defines a low pressure. If everything else around it is higher than that, then we're going to define that as a low pressure. Same with a high pressure. If everything else around it is lower than, then it's definitely going to be the highest pressure in the area, and that's when it's going to define it. Okay, so I'm starting to see my 1012 kind of break off here, right? I think that there's some lines that need to be reorganized. So how do we kind of grasp those 1012s unto themselves, yet also kind of make it be known that, you know, there's an isolated low pressure system here? Well, maybe there is a system that is also an isolated high pressure system. And I definitely see one now. I switch over to the blue and I see a 1016 all by itself right here. There's an isolated high right there. I put a high pressure, 1016 is an increment of 4. There's my isolated high. Okay. Now my 1012 might be able to go around that. There might be an opportunity, but it looks like, I found it, kind of. There's 1012 right there. These two numbers need to hit each other, right? There's my exit, 1012. Do I see another way for it to go? The sad part is not really, because it goes from 1016 to 1015, and oh, do I have an opportunity here? I do. Now here's what's weird. This should be able to come all the way across and hit this. My problem is that I'm in between 1016 and 1014, but we have no idea if there's any number there. I think in this case it is appropriate for us to draw that line because the data is not provided. And we can continue with that 1012 right there. Whew! And there's only one thing that I noticed that is kind of crazy here. And this might even confuse things a little bit more. There's a 1012 right here. Now, can I grasp that 1012? The answer is yes, I can grasp that 1012. I just got to bring it down like that. Get that 1012. Come all the way like that, and I can go 1012 like that. And there's 1008 right there. That's kind of off by itself as well. That's another isolated low pressure. And now you can say to yourself, oh my gosh, I can't believe it, he's finally done. Did he even know what he was talking about? Well, this is the problem with realistic maps like this, right? It makes it hard for humans to do something when there's data that is constantly changing. But when we look at the finished product that a supercomputer is actually provided, not humans, right? This is not why I'm expecting you guys to do this stuff. We can make a number of different conclusions. And this is going to be what the next lesson is. And I want to show you that right before we move on to give you a little precursor as to what you're going to be seeing. Now, you're going to notice some areas on this map, right? Those lines are really tight and close together. You're also going to notice that there are some areas on this map where there's barely any lines at all, right? This is a huge determining factor when we want to figure out what wind speed is, okay? If those isobars are close together, that's telling us that there's a huge pressure change there. If there's a huge pressure change, how do I know? Well, because there's a lot of change of 4 millibars there. Each line is 4 millibars of change. If they're really close together, that means that there's a huge gradient, a huge pressure difference. That means it's going to be high winds. It's going to be very windy there. Kind of cool that it's in, like, the Midwest, right? Like, Chicago's the windy city. Here's Chicago right here, right? And isobars are pretty close together. Out here in Wyoming, right, those isobars, and in Florida, there's a calm winds. The isobars are very far apart. The pressure differences are not that much. So something to keep in mind. We will also describe in the next lesson what those high pressure systems mean in terms of weather, what those low pressure systems mean in terms of weather, and I've already alluded to that in previous lessons. So if you stuck around this long, that's pretty impressive. I know that you saw me trying to work through this, and you know, maybe you might have come up with a different solution yourself, and that's great. But you know, what we're trying to do here is create lines to come to conclusions. The conclusion lesson, that's going to be in part 3 of air pressure that will be posted next week. But for these isobars, you know, it's not going to be this difficult, but if you can understand how I just did something like this, the ones that you're going to see in the worksheet and most certainly on the test, which are going to be easier than the worksheet, are going to be super, super easy for you. So thank you so much once again for listening to this iPad lesson, which is a little bit different from the screen share one. And if you have any questions, as always, please email me or message me on